Hello. Today in geometry, in this video, we will be discussing in geometry topic about triangles. In this video, we will be discussing about what all things, types of triangle, some of the angles of the triangle, exterior angle of the triangle theorem, and some other properties of the triangle, and also the Pythagoras theorem. I am Jui, and my qualification is BSc, MSc Applied Physics. Today in triangle, we will see what does a triangle means. Now you see from the definition, a triangle is a polygon with three edges and three vertices. What does this polygon means? A polygon means a defined number of finite number of lines when they intersect and form a closed figure. Now you see in this triangle, the figure, it's a closed figure. From one point it is beginning and then in the other point it is ending, and it is having a finite number of edges. Now you see here we have three edges. In a triangle, this is the basic structure in geometry. It will have three edges, that means three line segments, and three edges will meet each other at three different points: vertex 0, vertex 1, vertex 2. And because of these vertices, we will have three different angles: one angle here, one angle here, and one angle here. As per the Euclidean geometry, when any three non-collinear points intersect, then there we can find from these three non-collinear points, we will have a unique triangle. That means from these 3 points, we will have one and the only one triangle from these three non-collinear points. Now the question arises, what is the meaning of this non-collinear point? What is collinear? 2 points has to be collinear because from these 2 points, like these 2 points are there. These 2 points, when they are being met with a line, joined with a line, they has to be collinear. They are in the same line. The third point, it is not very important that the third point has to lie on this point. If it is lying on this line, then it is called a collinear point. And if the point like this vertex 1 is outside this edge 2, then edge 0 and edge 2 are collinear, but edge 1 is non-collinear because it is not lying on this edge. So we have three non-collinear points, and from these three non-collinear points we will have a unique triangle. That means we will have one and only one triangle from these particular three non-collinear points, and it will lie on this one on a plane. That means that this triangle is a two-dimensional figure. It will have a unique plane. That means like this computer screen, on this plane this triangle figure is lying. So a triangle will have three edges, three vertices, and three angles. That means at three vertices we have three different angles. Now, about the basic properties of triangle, what we will be studying in this video is that the sum of the angles of the triangle, like angle ABC, that is this triangle, this angle of the triangle, this angle of the triangle, and this angle of the triangle, and their sum will be 180 degree. How it is will be, we will be learning in the subsequent slides. And then sum of the any two sides will be greater than the third side, and the difference between the any two side will be lesser than the third side. And the exterior angle, that means at point any vertex, if the other side, if the line is being extended, the exterior angle will be equal to the sum of the opposite two interior angles. All these properties we will be learning in the subsequent slide of this. Now let's see what are the types of the triangle. These two types are there. One has been classified according to the sides of the triangle. First one is the scalene triangle, then the isosceles triangle, and then we have the equilateral triangle. That is, this is being classified according to the considering to be the sides of the triangle or the edges of the triangle. Now the second one will be if we consider the angles of the triangle. As in previous slides we have studied that a triangle is having three angles. So if we study according to the angles, then we will have three types of triangles, that is acute triangle, obtuse triangle, and right triangle. Then we can mix and match all these two types according to sides and angle, like scalene, acute triangle, like isosceles, right triangle, like that. We can mix and match and make other types of triangles also. But basically, these are the six types. Three types. One is according to the sides, according to the angles. Basically, there are six types of triangles. Here in the picture, first we will be studying about the types of the triangle according to the sides. Now we will be considering the sides of the triangle. The first one we are seeing is the equilateral triangle. In the equilateral triangle, the three sides of the triangle will be having are equal in their length, that is equilength. That means a equilateral triangle is a triangle in which three sides have the same length. So since they have the same length, their angles will be 60 degree, 60 degree, and 60 degree. How it will be, that we will be learning in the subsequent slides. Now next one is the isosceles triangle. What is an isosceles triangle? Isosceles triangle when any two sides of a triangle are of equal length. Like here we will be studying that two sides are equal, and if two sides are equal, then the opposite two angles will be also equal. Then the third one is the scalene triangle. Scalene triangle, here all the other sides, all the three sides have three different lengths, are of three different lengths. This these two lengths are same, and the third one is not similar, but the two are equal. In this, all the three lengths of the triangle are different. According to the angles, now we see acute angle triangle, right angle triangle, and obtuse angle triangle. In acute angle triangle, all the three angles will be acute. That means less than 90 degree. All the three angles will be less than 90 degree. Right angle triangle. In right angle, one of the angles, the other two has to be acute. One of the triangle, if it is 90 degree, exact 90 degree, then we will say it's a right triangle. And in obtuse triangle, one of the angles has to be greater than 90. The other two, obviously, it will be less than 90. But if one of the angle is greater than the 90 degree, then it is a obtuse triangle. But in an acute angle, all the three will be less than 90 degree. All the angles will be acute angle, then we will have a acute triangle. Right angle, once again, one of the angle, if it is exact 90 degree, then this triangle will be called as a right triangle. And obtuse angle, if one of the angle of the triangle is greater than 90 degree, that is if it is obtuse angle, then that triangle will be called as obtuse triangle. Now in this figure you can see the first figure is a equilateral triangle. All the sides are equal, so all the angles will be equal. Next is a right angle triangle because it is having one of the angle as 90 degree. The next is the isosceles triangle. Any two sides has to be equal. If the two sides are equal, then the corresponding two angles of the triangle will be equal. Scalene triangle, no angles are equal, neither the sides are equal. Acute angle triangle or acute triangle, all the three angles has to be less than 90 degree. Like here you see. Now we will be studying about the sum of the angles of the triangle. Now here we have in a triangle we have three angles: angle 1, angle 2 and angle 3. According to this theorem, it is angle 1 plus angle 2 plus angle 3 has to be 180 degree. That is, the sum of the angles of the triangle is 180 degree. Now, how we can say all of a sudden randomly that it is 180 degree? It is not random. We can prove it. How we are going to prove it? We can prove it from this video, from this figure. Here you see ABC is a triangle. From point P, we are drawing a line BD which will be parallel to AC. You see BD line which is being drawn in blue, and here an arrow is also there from A to C. That means BD is parallel to AC. Now, if we see this point, from this point at the vertex P, we have another angle 4 and one angle 1. So, here AB is the transversal which is intersecting two parallel lines BD and AC at point B and at point A subsequently, correspondingly. So, according to that, angle 1 and angle 4 are alternate opposite angles. They are within the two parallel lines and just in the opposite direction of this transversal AB. So these are alternately opposite angle, and when these two are parallel lines, BD and AC are the parallel lines, then these two angles are congruent. That means they are equal. And similarly, angle 5 and angle 3 is equal. Here the transversal is BC and angle 5 is in the other side or the right side of this transversal, and 3 is on the left side, BC transversal. So these two are within these two parallel lines, BD and AC is its interior of these two parallel lines. So these two are equal and they are alternately opposite angle. So now next we see, since BD is a straight line, so angle 4 plus angle 2 plus angle 5 has to be 180 degree, as the angle of a straight line is 180 degree. This angle 4, angle 2 and angle 5 is a supplementary angle. You see, they form a straight line. So BD is a straight line, it has to be 180 degree. So angle 4 plus angle 2 plus angle 5 is equal to 180 degree. In place of angle 4, we can place angle 1. Since angle 4 is equal to angle 1, alternate opposite angle, and angle 2 has, as it is, and in place of angle 5, we can place angle 3. So, through this proof, we can say that angle 1 plus angle 2 plus angle 3 is equal to 180 degree. So, we have proved that the angles between the triangles and their sum will be exactly 180 degree. Now, in case of a equilateral triangle, it will be equal to, each angle will be equal to 60 degree. Equilateral triangle will have all the sides are equal. Since all the sides are equal, all the angles will be also equal. So it has to be 60 degree. How it is? You see, angle A plus angle B plus angle C is equal to 180 degree. This is what we have studied and we proved it that it has to be 180 degree. But you see, angle A is equal to angle B is equal to angle C. They are equiangles since they are the angles of an equilateral triangle. So if we divide 180 degree 3 times equally, so we get 60 degree. So from this we can prove this angle and this angle and this angle is 1/3 part of 180 degree, that is 60 degree. So now we see another case, as if we see a right angled isosceles triangle, that means at one point it is a 90 degree and other two are equal. If these two angles, these two sides are equal, so what is the value of the angles of these two angles of this triangle? Since they are this is an isosceles triangle. One angle is 90 degree and other two angles are equal since the sides BC and AB is equal. So what it will be? From here you say if it is considered as x plus 90 is equal to 180 degree, that is 2x, and here 90 goes here, 180 minus 90, that is 90. So x is equal to 45 degree. Here you see it is because AB equals to BC. From the figure you can make out. So angle A will be equal to angle C. So angle B, since angle B is equal to 90 degrees, so other two angles will be 180 minus 90, then we will be dividing it into half, that is 45, 45. Now we are going to see the next property of the triangle, that is called exterior angle theorem. What is being said here? The exterior angle of a triangle is equal to the sum of the two opposite interior angle. Like this, we have a triangle, and if this triangle, one of the edge has been extended to the opposite side. So when it is being extended, so at that point we get another angle which is outside the triangle. So value of this angle is equal to the sum of the two angles which is opposite and inside these two angles, that is sum of the two opposite interior angles. Interior means it is inside this circular figure, that is triangle, and this is outside the triangle. So here we see D is equal to A plus B. Now we are going to see in the next slide how we can prove this theorem. Now see in this figure we see triangle ABC. At angle A we have the value is small a, at point B we have the value of the angle small b, at point C we have the value as point C, the value of the angle is small c. Now you see when this AC edge has been extended to point D and to infinity, we get at the edge point C vertex we get another angle. Let's denote it as small d. So this will be equal to A plus B. How can we prove that? Now you see at this point this angle plus this whole angle, this exterior angle, will be equal to 180 degree since AD is a straight line at point C. So here C plus D will be equal to 180 degree. And in the previous slide we have learned that the sum of the angles of the triangle is equal to 180 degree. That means A plus B plus C, small a plus small b plus small c is equal to 180 degree. Now you see C is common here and the right hand side of both the equations are common. From this we can interpret that this D is equal to A plus B. So this way we prove that this at this point this point if we have a D, so this D is equal to A plus B at this point. This angle will be equal to the sum of the angles of the interior angles of the opposite interior angles. This is opposite, not this interior. We are considering this exterior angle. So inside interior opposite angles and their sum A plus B. Now in the next slide we see some more properties of the triangle. Is that a triangle that longer side has the greater angle opposite to it. Now in this triangle, in this figure you see ABC is the triangle. In ABC you can see at point P we have a obtuse angle. That means this is an obtuse angle, that means it will be greater than these other two. Because if one angle is obtuse, the other two has to be acute. Then only we can get the sum of 180 degree. So if these two are acute, so at this point angle B will be obtuse angle if we take, that means it's the greater angle than other two angles. So in this, AC will be the greater side than AB and BC. That is, AC will be greater than AB plus BC. If angle B is greater than angle A and angle B is greater than angle C. So here in this figure we have taken B as an obtuse angle. So obviously it will be greater than angle A and angle C. So the greatest angle, the side opposite to this greatest angle will be greater than the other two sides of the triangle. Now we are going to see the most important thing about the triangle is Pythagorean theorem. In this Pythagorean theorem, we will be considering right angle triangle. The Pythagorean theorem, the most important thing is that what triangle we consider? That is a right angle triangle. Here we see it's a right angle. That means at this point it is 90 degrees. According to Pythagorean theorem, the fundamental relation is that the square of the largest side, since 90 degree, so the opposite from the previous slide we have seen the greatest angle, and the side opposite to this angle will be greater than the other two sides. So this side is called as hypotenuse. So hypotenuse, that means C, this side's length square will be equal to the sum of the squares of the length of the other two sides. If we see, this side is A and this side if the length is B, so A square plus B square is equal to C square. The sum of the squares of the other two sides. From this Pythagoras theorem, we can find out the length of the other side of the right angle triangle. Like in this formula, we said that hypotenuse square is equal to the sum of the squares of the other two sides of the right angle, that is a square plus b square. So C can be square root of a square plus b square. So it has to be positive since we are considering the length. So similarly, if we see from a square can be equal to c square minus b square. So a equals to square root of c square minus b square, and similarly for b, base side, we can say that equals to square root of c square minus b a square. Next in this the other videos, we will be next studying about the congruence of the triangle, then the different formulas to calculate the area of the triangles, and then we will be studying about trigonometry. From now, thank you very much. If you like this video, please click like, do share and do subscribe.